If ever there was a question to test our full understanding of this unit, it would be class example 2.36. Here, we're given a polynomial function of the 5th degree. One of the coefficients within the function is unknown and is represented by k. We're told that two of its zeros are -1 and +2, and that the largest zero can be written in the form a plus root b. We're asked to find the values of a and b, so effectively we need to find the largest zero. Knowing that we have a zero at -1 and +2, we can determine that two of the factors will be x plus 1 and x minus 2. We'll divide these out later. Also, because we have no constant term, we see that every term has a common factor of x and can factor it out. In order to determine the value of k, we'll now use our factor theorem. If -1 is a 0, then we can replace every instance of x with -1 and set the polynomial equal to 0. Notice here I have a -1 out front of the square brackets. That's the factored out x. In the next step, I divided both sides by -1. So that factored out -1 went away, and on the right side, 0 divided by -1 did not change. We isolate k to find it has a value of 12. We would have found the same value had we replaced all the instances of x by 2, because it's also a 0 of this function. Now we need to divide out our factors, but it won't matter in which order we do this. We'll do one and then we'll do the other. By this point, hopefully you're comfortable with the steps of synthetic division. The remainder of 0 confirms we've correctly divided out the factor, and the remaining quotient will move forward, and we'll divide out the next factor from this. So notice, in this second instance of synthetic division, we're not reusing the same coefficients as the first time because we've already taken out the x plus 1. Now that we've taken out both factors, we're left with a quadratic. Remember, the x out front is because it was a common factor. The x plus 1 and x minus 2 were given as zeros. Now we'll need to use that quadratic trinomial x squared minus 2x minus 6 to find our other zeros. Given that x squared minus 2x minus 6 does not factor over the integer numbers, we'll use our quadratic formula. After simplifying, we find 2 plus or minus the square root of 28 over 2. But this is not the same as the answer we're looking for, which should be a plus root b. We'll need to simplify more. After writing root 28 as a mixed radical 2 root 7 and factoring out the common factor of 2 from the top and bottom, we reduce this down to 1 plus root 7 and 1 minus root 7. If you think of these as decimal numbers, 1 plus root 7 is larger than 1 minus root 7, and 1 plus root 7 is larger than 2. 1 plus root 7 is therefore our largest zero, and the answer to our question is that a is 1 and b is 7. Sometimes a graphing calculator will allow us to skip algebraic work and solve a problem technologically. In this example, we can't really skip the algebraic work, but we can confirm our answer and verify with the calculator. We found the fully factored form of our polynomial to be as written. After using the quadratic formula on that last factor, the x squared minus 2x minus 6, we determined the largest zero was 1 plus root 7. If we put our original polynomial, with the k replaced with 12 of course, into our calculator, we can check the zeros. Here we find the rightmost zero to be 3.6457513. Now, go to the calculating screen and determine the value of 1 plus root 7. Notice it gives the exact same decimal value. This means that 1 plus root 7 is indeed the largest zero of this polynomial.